Dear students, I am going to start the fourth module today. And in the fourth module, there are three chapters. First is changing user IDs and group IDs. Second chapter is overview of IPC methods. And third chapter is shared memory. So let us start with the first chapter, which is changing user ID and group ID. First module, first chapter is changing user ID and group ID. So before we should know how to change the user ID and group ID, we should know what are the different types of user ID in Unix operating system. So every user in Unix like operating system is identified by different integer numbers, and this unique number is called a user ID. So whenever a user login into Unix operating system, with its login there is an integer will be associated with its login, and that integer is called its user ID. So there are three types of user ID defined for a process which can be dynamically changed as per the privilege of task. So total three types of user ID will be provided to the user whenever he or she logs in. Then those three types of users are real user ID, effective user ID, and saved user ID. So let us study, because it is user ID which makes a user to be identified in the Unix operating system. So many users will be logging in the Unix operating system. So in order to identify which user has done what work in the Unix operating system, the Unix operating system has maintained a user ID with each user who logs in. So let us see what is real user ID. The real user ID, it is account of owner of this file, this process. So whenever we log in, so that number will be associated with the user, and this it accounts the owner of this process. Which process and using real user ID, we can identify who is the owner of the process, and it defines which file that this process has accessed. So it allows the which process can ID is effective as real user ID, but sometimes it is changed to enable a non-privileged user to access files that can only be accessed by root. So effective user ID, it allows a non-privileged user to access a files which can only be accessed using the root user ID. So that is a effective user ID. Next, saved user ID, and it is used when a process is running with elevated privileges. Generally, root needs to do some underprivileged work, and this can be achieved by temporarily switching to non-privileged account. Means sometimes some user has high privilege and it has to do some work which can be done with underprivileged. So in that case, we need saved user ID. So while performing underprivileged work, the effective user ID, which is elevated user ID, effective user ID is changed to some lower privilege value, and the effective user ID is saved to saved user ID, so that it can be used for switching back to privileged account when task is completed. In the simple manner, I can say that whenever user logs in, it will be and it starts a process, then a real user ID will be provided. So using real user ID, we can understand who is the owner of a process and what all the files that process can access. Next is effective user ID. So some tasks can be done with high privilege. Okay, so that time we can change the real user ID to effective user ID. And similarly, suppose some effective user ID, some process has effective user ID and it has to do some underprivileged task, so that time it can change to the saved user ID. Means effective some high privileged work can be done using the effective user ID, and low privileged or non-privileged work can be done using the saved user ID. Next is changing user IDs and group ID. How we can change? So when our program need additional privileges or need to gain access to resources that they currently are not allowed to access, they need to change their user or group ID to an ID that has the appropriate privilege or access. So suppose a user is there with some privilege. Now it wants to access the file, but that user doesn't have the privilege to access those files. So that time we need to change the user ID. So similarly, when our programs need to lower their privileges or prevent access to certain resources, they do so by changing either their user ID or group ID to an ID without the privilege or ability access to the resource. So similarly, when a program needs to lower their privilege to do some work or to access some resources or to prevent some resources, that time also we need to change user ID or group ID. How we can change the user ID and group ID? Suppose you want to suppose you want to uh, make the say you want to set the user ID, then we can use this hash include unistd.h integer set user id underscore t uid, and integer set group id underscore t gid. On successful, they both return 0 or else it will return -1. There are rules for who can change the IDs. Let's consider only the user ID for now. If the process has super user privilege, super user means like root and all those things. If the process has super user privileges, the set UID function sets the real user ID, effective user ID, and saved set user ID to UID. If the process does not have the super user privilege,